Hi everyone, welcome to our session Get More and Spend Less with Loki. We've got quite a lot of ground to cover today, but stick with us to the end because we've got a Q&A and we will answer any of your questions that you have relating to what we discussed today. I'll be taking you through a quick introduction to Loki and what's new since version 2. Cyril is going to take you through LogQL and how to get more from your logs with it. And Jen and Levi are going to take you through access controls made easy with Grafana Enterprise Logs. Why Loki? If you need a service that stores your logs very efficiently and at very low cost, Loki is definitely the right solution for you. It's very easy to run, so you can run it as a single binary. You can run it as a bunch of microservices in Kubernetes. We really support a bunch of different deployment solutions, and it's very low cost to run. We don't heavily index all of the logs that come in, and so you don't get these massive files that you need to store or use a lot of memory. So you can run Loki at very low cost. Loki will be very familiar to you if you've used Prometheus or Cortex. The language LogQL, which you use to query your logs, is very similar to PromQL. So you should be able to get started quite easily if you've used Prometheus before. And Loki is deeply integrated into Grafana, so you get first-class support for the LogQL language and some very interesting features like live search and things like that. My name is Danny Copping, and I'm a software engineer here at Grafana, and I'll be taking you through what's new since Loki 2.0. So we released Loki 2.0 about a year ago, and in that time, we've been focusing on performance and stability. And I'm very pleased to say that the team have done a great job here. And so Loki is much more efficient in terms of resources to run since then. And we've also added some features, which we'll be discussing now. One of the more interesting features is custom retention and deletion. And what this allows you to do is to change the amount of time that you store logs for based on different conditions. So you can change the retention per stream or globally for a particular tenant. And so let's say, for example, you have a very high throughput stream. You only want to keep those logs for a couple of days. You can do that now. Or if you've got some very sensitive logs and you want to store those for a much longer period of time than you do all the rest of them, this is also made possible through this feature. Look out for a blog post on this in the near future as well. And this feature is currently experimental. A feature that is stable in Loki is scraping the Windows event log. This will be very interesting for you if you run a fleet of Windows servers. And say, for example, you've got a bunch of servers running SQL Server. Those are all pushing logs to the Windows event log. Now you can scrape those events with Promtail and send them to Loki, and then alert on that data and visualize them in order to administer your Windows servers very efficiently. Multi-line logs, this is a feature that has been requested for some time, and we've implemented it recently. This is also stable. So let's do a little exercise here to demonstrate how this works. Can you spot all the individual log messages in this text over here? So you're probably thinking that these are the individual messages, and you'll be correct. However, Loki by default will see all of those as the individual messages. So what you need to do is you need to enable multi-line logs. This feature, there's a pipeline stage. So you enable the multi-line pipeline stage, you configure a regular expression, and then that will tell Loki to look for that regular expression. And then when it sees that, consider all of the lines that follow as relating to that initial line. So that's really great, as in this case where you want to capture a whole stack trace, for example. And now we're going to spend some time talking about recording rules. This is a very interesting feature, and it's currently experimental. And recording rules currently exist in Prometheus, and we're bringing them into Loki now. So what exactly are recording rules? Recording rules you typically use when you have a query that's run over a very large data set, and that query can sometimes take some time, unfortunately, if that data set is sufficiently big. So what you have with recording rules is a way to run these very complex queries, but over a very short period of time. So you run them regularly over a short period of time, and then we take all of the resulting samples from those queries and effectively combine them together, and then you have data that covers the entire period of time that you would have queried previously. So if you're querying a period of a week's worth of logs, and you run this recording rule every minute, you'll have a sample for every minute of that week. The really exciting thing about this in Loki is that now you can take logs, run metric queries on those logs, and produce real Prometheus metrics. Prometheus, since version 2.25, has allowed you to push metrics directly to it rather than its traditional pull mechanism. And for other Prometheus-like systems like Cortex and Thanos, they've had this feature as well for some time. So now we can push metrics directly into Prometheus, Cortex, and Thanos. And this is particularly interesting if you've got old software that you can't instrument with Prometheus metrics, but you have logs. You can now take those logs and turn them into metrics, which is exactly what we're going to demo now. Let's just quickly cover how these recording rules look. So this is what a recording rule looks like in Prometheus. You specify a name, how often to run it, the metric name, and then the query. So this is just a PromQL query, which results in a few metrics once this query returns, and then those queries, those metrics are sent to Prometheus. And in Loki, it's exactly the same, except now we're running logQL instead of PromQL. So let's have a look at the demo for this. In this demo, I'm going to show you how we can extract a metric for the number of failed logins and valid logins for an OpenSSH server. So OpenSSH, for those of you who don't know, is a server that allows you to remotely log into servers and gain a shell. OpenSSH is a great example of very old stable software that you might have running in your architecture, but that doesn't have Prometheus metrics. And in fact, OpenSSH is so old that some of our Prometheus maintainers were still in diapers when it was first released. So this is a great example of old meeting new. So over here, we have two recording rules, one for failed logins and one for valid logins. And that all looks a little bit unfamiliar at the moment, but let's see how we can make that a bit simpler. So I'm going to run this command here that attempts to log into this SSH server, but is constantly failing. And now you'll see, if I look at the live logs here, you'll see that there's a bunch of these messages saying connection closed by authenticating user, and then it gives the username. So we can use that as an indication of a failed login. So if I just close this here. So we're looking for a count over time. We're looking for the pre-auth message, so before it's authenticated, and we're going to look for this message, connection closed by authenticating user, and then we're capturing that user as a label. And then we're going to do a count over time aggregation over that, and then sum by that particular user. That metric query, if we run it on its own, let's exit out of live mode here and run it on its own, you can see that we now have some logs being produced, and we have these point in time numeric values. And so this is an example of a metric query. And so these metrics, along with the labels, are going to get sent to Prometheus. And so now if we have a look at the failed logins metric over here, we can see pretty much exactly the same data that we saw just now from that metric query. And so I've got a dashboard over here that shows all of those failed logins over time. And now if I do a successful login, you will see that a valid login will display over here. And this is another metric that we're sending to Prometheus directly from Loki. So we think that this is quite an interesting feature to be added to Loki, and we hope that you can make great use of this with all of your legacy applications. And now I'm going to hand over to Cyril, who's going to show you how to get more from your logs with logQL. Cyril?
Thank you, Danny. That was awesome. I'm really excited about this recording features. Being able to use logs for creating metrics will open up so many new possibilities. So to write those recording rules, you'll need to write LogQL, the query language for Loki. And that's what I want to talk about during this segment. So let's talk about LogQL, dig into how the language works. First thing you'll notice is LogQL is heavily inspired by PromQL, the Prometheus query language, the one that you use to query metrics in Prometheus. In fact, that's not the only inspiration. Prometheus and Loki uses also the same label concept. Because it's heavily inspired by PromQL, it means that you don't need to learn a new language. You know, learning a new language can be intimidating. I remember myself, the first time I learned PromQL, you know, it took me some time to really get used to the language and be very efficient. And you're not going to lose that if you switch, not switch, but if you start using Loki, you can apply all the things that you already know in PromQL and in Prometheus to Loki with LogQL. So let's talk about the philosophy of the language. I think it's important to understand how the language works to grasp the idea of how to use it. When we designed LogQL, we made sure that it was easy to understand and easy to learn. For that, we wanted to never mix the two logs and metrics primitive. So for example, when you're working with logs, you will always be working with pipe operation. So we'll be always chaining pipe operator. It works a bit like if you were using a Linux command line tool and you can pipe multiple commands. In fact, it's like a pipeline. Your data go through from left to right and it gets filtered and mutated along the way. For example, on the screen right now, you can see that we're gonna select all the logs that are coming from the application NGINX using the label matcher here. Then next, after, we're going to only filter and keep the logs that are having the word user logging. We'll pass the JSON log line and extract all the property as labels. One of them is duration. And then we're going to only show the log line that have a duration or latency higher than 10. If you're not using JSON logs, no problem. We have other parser like regex or log format that you can use to take advantage of parsing logs. So that's for operating on logs. There is other operator, but that just gives you a glimpse of how it looks like when you're operating on logs. Now, when you want to create metrics, you use function. And you use the same function as you are using in Prometheus. So all you need to do is take the operation that you've done on logs and wrap it with overtime function. In fact, the same overtime function that we have in Prometheus. We support, quantile, average, standard deviance. All of them are actually available in Loki. Then you can use the classic operator to aggregate over different label dimension. Like here, I'm using a sum by path. This is the same as in Prometheus. Just to emphasize on the fact that it really is the same when you're doing metric query. This is a more complex example. This example is basically calculating the ratio of error on the logging path. And it shows you that you can do binary operation like you will be able to do in Prometheus. So this is a LogQL query, but there's a lot of similarities with PromQL. So LogQL is obviously allows you to search. That's the first use case. Allows you to search for your log so that you can troubleshoot your problem. But not only it does that, but it can allow you to also extract metrics and do some black box monitoring. It allows you to create alerts, but also recording rules and so metrics. And it's using the same ruling and alerting concept as Prometheus. And finally, all of this is well integrated into Grafana. And so you can build nice real-time interactive dashboards. So since we released LogQL, the community has been super responsive, and there's a lot of great feedback and creative people around the world that have created awesome dashboard using LogQL. So I just want to go through a couple of interesting use cases. The first one is the perfect example of black box monitoring. This is Ward's dashboard, probably one of the most popular dashboard, Loki dashboard on Grafana.com. And it uses Loki LogQL to parse NGINX access log and then create a fully fledged dashboard that give you quickly a glimpse of how looks your traffic around the website. What I really like about this dashboard is that Ward was able to extract the country code from the log line using LogQL again, and then map that into a map panel. This is awesome. I just want to emphasize on the fact that this dashboard here is showing that it was crunching 1 terabyte of data. So it's pretty cool. Another dashboard, just to remind everyone that PromptIO supports Syslog, and Dave at Grafana created a nice dashboard, also available on Grafana.com, that shows you how you can combine metrics and logs. All of this is from Loki, and it shows rate per application, rate per host. Very good example here. This example here is using the Opsgenie Kubernetes event exporter, which is an exporter that you install in your Kubernetes cluster, and then it will log every Kubernetes event as a log line. Xavier here created a nice dashboard that gives you a quick glimpse into your Kubernetes cluster health using this exporter. It's really nice because it shows you, if there is any issue currently running, and also what's the most appearing Kubernetes events. Another super interesting use case here is from our one and only Marco at Grafana. He created a dashboard using a table panel that shows you the slowest query in Cortex from the users. I really like this dashboard for 2 reasons. The first reason is because it uses a table. You can actually sort the table using different fields like latency, step, or time range, right? That's super, super interesting, so that you can actually order by the highest latency and then start working on those queries first. And then second, what I really enjoy is that he created a trace fields that you can actually click on it, and it will jump automatically to Tempo or tracing backend at Grafana Labs. If you look at the top, you can see that also you can actually change the minimum duration for filtering the slowest query. So here we're going to only show queries that are higher than 9 seconds. This is a really nice dashboard. Not everyone is using the table panel with Loki, and I think this is a very good example of why sometimes you should do that. Last but not least, Dave Smith from Grafana again shows his impressive dashboarding skills. He uses a weather flow sensor and output logs from this sensor of a weather station. I think it's very cool, really showing that Loki can also shine in the IoT space. This is very good dashboard from Dave here. So let's take a moment to talk about what's the future for LogQL. What do we have in store? So the first problem we want to solve is we want to improve the experience of parsing human readable log format. Because this is the type of logs that you should be having, right? That's the best practice that you should be following in logs. Your log should be human readable. Like JSON is not really human readable. I know a lot of people are using JSON, but when you have a ton of JSON on screen, it's super hard to glimpse at it and maybe find a problem. So we want you to improve. We want to improve the parsing of those human readable logs. And on screen right now, there is the one popular human readable log is the combined log format, which is used by NGINX and HTTPD, I believe. And it's pretty simple to read. If you have 1,000 lines like this, you can quickly glance at it because it's all well spaced all together. Now, the problem in Loki is if you want to extract data using a regex parser, it gets very complicated, right? That's how the regex look like. Obviously, I wrote that regex, so maybe there's a better way to write this regex. But you get the point. This is not a good experience. Very difficult first to explain to your colleague what it does, and then it's most likely our problem. So how do we want to improve the experience? Well, we want to allow you to parse human readable format with pattern matching. So we want to include a new parser that will allow you to write a pattern, write captures, write tokens, how the log line looks like, and then Loki will automatically extract the data that you want to extract. As you can see here on screen, this is an example of this parser. It's very much easy to actually read the pattern itself. And so it's easier for you to understand and to take advantage of human readable logs. I just want to add also that on top of this parser will be faster than executing regex or JSON parser. So there's two other points on performance. We want to always strive to improve the performance of LogQL. Currently, there's a dark spot around counting very high cardinality logs, and so we want to tackle this count distinct problem via estimation, which should allow you to maybe get the top hits per IP or even detect if you are currently having a denial of services. And finally, we want to improve the performance of instant query, which are heavily used for ruling and alerting. They are not very super parallelized right now, and this is something that we want to tackle next. And that's pretty much it for me. Next up, Jen and Levente will talk about Grafana enterprise logs.
Cyril's presentation gave you a taste of some really cool things you can do with LogQL. However, in the case you're at a large company, you're going to have to overcome a couple challenges before you can deliver that sort of awesome Loki experience to your end users. In this presentation, I'm going to walk you through a few of those challenges, how you could solve them on your own, and how we built an enterprise product that solves them for you. I'll be joined by my colleague, Levi Balag, and my name is Jen Villa. All right, let's start by picturing your hypothetical large company. You're going to have lots of different groups sending logs to Loki from a bunch of different applications, and then all using LogQL to query them back. With all these different groups using Loki, things can get a little messy. A developer from Team A may see logs from Team C returned as part of their queries, which can get a little confusing. Team D then may start writing gigabytes of logs a second, degrading Loki's performance for everyone else. Fortunately, Loki was built for multi-tenancy, which helps solve this problem. This feature allows you to isolate different groups from one another so that each can enjoy use of Loki without awareness that others are using it too. It's sort of like how you can have a single apartment building where each renter gets their own private space. By setting up separate tenants, you can ensure that each team's logs are isolated and set unique read and write limits for each of them. However, Loki's multi-tenancy support lacks authentication. It's controlled by a single HTTP header, xscope org ID, which Loki trusts completely. So this means that any accidental or malicious read or write call could masquerade as a valid request for a particular tenant's data. This is problematic for companies where logs can contain sensitive customer information. Now, if you wanted to solve this problem with open source, you would build a gateway component. The gateway's job is to ensure that all callers, both clients sending logs over remote write and humans making queries to the cluster, will supply credentials which identify them and confirm they're authorized. If you check out GitHub, you'll find an open source Cortex gateway that's a good model to start with. You'd configure Promptail and Grafana to send JSON web tokens containing the tenant ID with each request they make. The gateway will then validate this web token, and if valid, will set the right HTTP header and pipe that traffic into Loki. With our enterprise logs product, we built this all for you and added APIs and a Grafana plugin to make this easy to manage. Not only will we authenticate the tenant ID, we'll also allow you to define scopes of access to that tenant, like read, write, or delete, so that you only have to give out the minimum set of access possible. I'm going to hand it off to Levi to show you how this works.
So just like Jen said, we would like to show you how it's possible to send logs to separate gel instances and only be able to access them with the right access policy. Let's say that we would like to create a new team called Team B, besides our already existing team, Team A, and that we also would like to create a separate instance for the logs. We create an instance, we call it Team B, we assign a cluster to it, and we also need to create a new access policy in order to read or write logs to this instance. As we can see, Team A already has its own. We are going to call this Team B as well. We assign the read and write permissions to the Team B instance, so the instance that we freshly created. This means that this access policy is only going to be able to access logs from the Team B instance. We also need to create a new token to authenticate to the access policy. We call it Team B logs. Good. First, we copy this token to the clipboard because we are going to use promptail to push logs to our instance. Let's go over to the promptail config. For the basic auth, we are using the name of the instance as a username and the token as the password. Everything else is going to be taken care by gel. Let's save this and let's start a new promptail container based on this config. So in the current example, we are running two separate promptail containers to collect logs for Team A and Team B. If we go back to Grafana, we can see that every time we create a token with read writes, read access, there is this button which we can use to easily create a data source and spare time for ourselves. Now that we know that logs are pushed to our instance, let's see if we can query them. We go to the Explore tab and we try to query the Team B logs data source that we just created. Let's say job equals Team B. Brilliant. We can see the logs coming from the Team B instance, or recorded to Team B instance. Let's see if we can check Team A's logs. No, we don't have access to that. Good. Let's check this thing from Team A's perspective. Team A has access to the logs stored in Team A, in the Team A instance, but it doesn't have access to the logs that are stored on Team B.
Now, while the tenant model is really powerful for isolating different groups from each other in your log cluster, sometimes it's not always easy to align how you split up your tenants with how you need to set up permissions. There are going to be cases possibly where you need to restrict access to a few log streams within a tenant. Or maybe it's operationally simpler for you not to use tenants at all, but you still want to control who has access to what logs. Let's look at this example I have here, where I have a single promptail scraping a Kubernetes cluster and then writing those logs to Loki. Because I'm using promptail's built-in Kubernetes service discovery, the logs I write are going to be labeled with the Kubernetes namespace they're scraped from automatically. Now let's say I have two engineers, Fiona and Shrek. Now Fiona is an engineer for the Kubernetes platform team, who's going to need access to logs from all the namespaces. Shrek is working on an application deployed to namespace A, so he should only get access to logs in that namespace when he queries Loki. How could I achieve this? Well, it turns out you could use building blocks from the open source community, specifically the kube RBAC proxy and the prom label proxy. The kube RBAC proxy is going to look up the caller's permissions, in this case, Fiona or Shrek, using the Kubernetes API, and then is going to forward on that request to the prom label proxy that you set up. The prom label proxy will take that caller permission info and use it to add a proper label to the caller's query. Shrek is going to get namespace A injected into his query, while Fiona will have nothing injected, since we want her to have access to all the namespace data. Now again, while this is totally doable in open source, we've built this directly into our enterprise logs product. So users can set access controls based on whatever label values they want without any extra work. Now Levy's going to walk us through what this looks like.
So let's see how we can control access between teams for logs that are stored in a single instance. We have created an instance called logs and an access policy called log collector, which has write access to the logs instance. And we also started a local Promptail container that pushes logs to our instance just to make the demo simpler. Now, just for the sake of example, let's say that we would like to create two groups: developers, who can only see logs that are coming from the development environment, and SRE leads, who can see both production and development environment logs. In order to achieve it, first we create a new access policy. Let's call it developers. We give read access to it, and we assign the logs instance to the access policy that we created before. Now, to restrict it even further, we specify a label selector environment equals dev, which means that only the logs that are coming from the development environment will be visible for the developers who are viewing them through this access policy. In order to authenticate to this, we need to create a new token. Let's call it dev logs. Good. As the Promptail is already configured, we won't copy this now, but just create a data source. And in the data source settings, first we check if the data source is working as expected. Good. Then we set up a new permission, so this data source is available to query for the developers team. I have another browser session for a developer already logged into Grafana, and let's check if we go to the Explore tab, if we can see the data source that we created. It's here. Great. Let's try to query it. So we try to query the dev logs. Okay, so we see the logs that are coming from the development environment. Let's try to query the production ones. We can't see any. That's exactly what we wanted to see. Okay, so next step is that we go back to our admin Grafana and the JAB plugin, and let's try to cater for the SRE leads scenario. We create a new data source called SRE leads. We also give logs read access to the logs instance. However, in this case, we won't specify any restriction with label selectors to this access policy. We just create it. We also need to create a new token. Let's call it like all logs. Let's create a data source. And here we grant permissions only to the SRE leads team. Good. I have another third browser session with an SRE lead. And let's see if it can see the data source and if it can query the development logs. Brilliant. And now if it can also see the production ones. Great. So as we can see, it can access both production and development environment logs.
Thanks again for joining us today. So just a quick recap of what we talked about. We hit on some of the new features released since Loki 2.0, showed off the power and flexibility of LogQL, and talked about how Grafana Enterprise Logs makes it easy for enterprises to bring Loki to their teams. And now on to the live Q&A.
Hello.
Hi, everyone.
Hello.
Hello.
Thanks for attending our presentation. We hope you found it interesting, and we're going to take some of your questions. So we're going to start off here. Let's start off with a nice easy one. Where can we find that fancy new Promptail icon? Jen, I think you had that in your presentation.
Yeah, so that is actually the logo that we have. for the Grafana agent. Let me see if I can get a link for that. Promtail itself, to my knowledge, doesn't have its own kind of standalone icon. But the Grafana agent is kind of Grafana's built on top of that, and that's going to actually bundle for you the ability to scrape metrics, logs, and traces all together.
Cool. We have a question here. Would it be possible to have subqueries in LogQL? Example, first query, find a list of user IDs, and then search for logs with these IDs. Cyril, do you want to take that one?
Yeah, sure. It's not the first time I've seen this question. So I would suggest that you definitively open an issue for that one. We don't have like any plan right now, but I could see how this could be interesting. Like use the result of a query to do another query is definitively something that is interesting. So yeah, no plan, but definitively interesting. So please do open an issue. We'll look at it.
Cool. We have a question here. If you run your recording rule every 1 second, so 1 second interval, but count the values over 30 seconds, won't you end up with a lot of duplicate values and not with the actual value? So all recording rule queries are run as an instant query. And so depending on the range that you go back, you'll always be fetching that amount of data, right? So if every 1 second you're querying back the last 30 seconds of data, you'll effectively be fetching 29 seconds too much every time. You won't end up with duplicate data because all of this gets deduplicated when it goes into time series. But yeah, it's probably not going to be optimal in terms of your querying. Here's another question. We're facing an issue while displaying logs in Grafana of max 5,000 lines. But when we're trying the same stuff using log CLI, it's possible to display all the logs. Who wants to grab that one?
Yeah, I can take it. Honestly, I don't know. But the best way to go about it is just to open an issue on the Grafana repo. I think it's most likely a Grafana issue with 5,000 line. So opening an issue will just let them know, and so they can look at it and try to work out a solution.
I think you may, I'm not sure if you've already tried this on Grafana 8, but I think this may be solved in Grafana 8 with some pagination. So maybe stay tuned or file an issue if you try Grafana 8 and kind of are still running into the same problem.
Cool. Will LogQL eventually, excuse me, will LogQL eventually support the functionality of Grok exporter, particularly supporting of GSub, which we use for sanitizing weblogs, removing GUIDs. We could currently do this with Promtail, can't we, Cyril? We can rewrite the data that goes in.
Yeah, we can do that with a regex replace all, I believe, which is part of the template stage in Promtail. But I guess you can also do that with LogQL currently. If you are using a line format stage in LogQL, then you should be able to catch GUID and then remove them or replace them. But I still like the idea of using GSub. And I think there is a replace all, so that seems to be exactly the same. We have a replace all. So yeah, I think it's already possible. You should check out the line format stage in LogQL.
Cool. What is the footprint of Loki? Is it intended for large enterprise, or can it run for compact IoT solutions? Jen Levy, one of you want to take that?
I would maybe bump this one back to Cyril. I haven't seen, I haven't worked with folks using it in the IoT space.
No worries.
Yeah, I mean, I guess the answer is yes for running large enterprise Loki cluster, and also yes for IoT solution. Not a lot of people are actually aware of that, but Loki supports ARM architecture, so you can run Loki on a Raspberry Pi. Actually, I know a couple of people out there who are doing that. So you could technically have a Raspberry Pi that has a Loki server, and you should be fine. However, you should know that deploying large enterprise cluster versus IoT solution is like two different worlds. IoT solution, you most likely want to run Loki as a single binary, which saves the logs on disk or maybe on object store, depends on your need. But I will use like just a single instance of Loki. And then if you need to deploy a large cluster to ingest, say, more than 1 terabyte a day, then in that case, you most likely want to use the distributed version of Loki that scales out much better. I mean, you cannot expect to receive large enterprise logs on a Raspberry Pi. So that makes sense that the setup is different.
Cool. Okay, let's try to find another one here. Does LDAP or AD use authentication and authorization work? And can I add the access rules via an API or deploy it via modifying a file? Jen?
Yep. So as far as the LDAP, AD, the way Gel would work here is that we integrate with Grafana Enterprise, which is going to have that LDAP AD sync. So that's how you can sort of map a user to a team and then kind of set permissions at a team level. And then the idea is what we give you with the Gel backend is the ability to set access policies that you would then say map to a team or an individual there. As far as setting them up, yes, we do have, we have an API. The API is actually what the plugin that we demoed kind of hooks into. So you can do that as well. Right now, you would not, you're not able to like statically you can statically provision some of these access policies on startup of Gel. But the way we envision users interacting with the access policies once the cluster is running is just via the API or the plugin. So you wouldn't be like changing the config files after boot of your cluster.
Cool. Great. Right, so we can maybe fit one more quick question here. What are the benefits of migrating from Elasticsearch to Loki, except cost saving? How does Loki perform with logs of 4 to 5 terabytes ingested per day? We've been doing quite a lot of performance improvements around this. Cyril, do you maybe want to grab this? I think you're muted, man.
Yeah, sorry about that. It's an hard question because cost saving is probably the first, like the biggest benefit of using Loki compared to Elasticsearch. Now, I guess the other big benefit is, in the tagline of Loki, like Loki, it's for the logs, but like Prometheus. So that means that if you're already using Prometheus, then there's a lot of the mental model of Prometheus that you can reuse, right? Like the labels, the discovery of the labels, like the configuration is also very similar. I mean, like if you're using already Prometheus, then you're gonna get a very good experience with Loki. Like there's not a lot to change. So that also means like less context switches, right? If you're using Elasticsearch, then you have to learn this Lucene language, where with LoQL, it's inspired by PromQL. So there's a lot of similarities in the language, and you can use that to quickly take advantage of your logs.
Great, cool. I think that's all we've got time for. So thanks again for joining us, and enjoy the rest of the conference.
Thank you.
Thanks, everyone. Bye-bye.
Bye.
Bye.
Hi, my name is Vincent. I'm working at Dailymotion, and I'm also a contributor to the GenkinsX open source project. And I'm going to talk about how we are using Grafana at Dailymotion and inside the GenkinsX project, and more specifically, how we are using it to visualize our continuous delivery indicators. So yeah, I couldn't have survived this past year without my wife and children. Tried to get a newborn child during the pandemic. It's an interesting experience, and yeah, you won't get bored. So back to our talk and the agenda. I'll start with our challenges and a quick overview of what is GenkinsX and how we are using Grafana inside GenkinsX. Then I'll get into more details into how we are using Grafana for our continuous delivery indicators and the benefits of it. And I'll finish with trying to get one step further. So at Dailymotion, we have a lot more repository and application and microservices than developers. So continuous delivery is a very important practice for us. So yeah, being able to evaluate it and its performance is critical for us. We need to be able to identify bottlenecks so that we can improve our efficiency. So that was our first challenge, but we ended up using Grafana to visualize our indicators. And then we had another challenge. We had multiple Grafana instances. So one for our continuous delivery indicators, one for our logs and metrics in our Kubernetes platform, and so on. So it brings a maintenance cost. Nobody wants to maintain multiple instances and so on. So we solved that by switching to a single shared instance. I'll explain how during the presentation. And then we had other challenge, like the dashboard ownership issue, with the multiplication of data source inside your single shared Grafana instance. You're going to get more and more dashboard using mixing of data source. And it's going to be difficult to maintain, to know which dashboard are maintained by whom and when and so on. So that's the last challenge. So everything we did it first inside Dailymotion, and we also shared everything we did with the GenkinsX community. So everything is open source because it's based on GenkinsX, so we are sharing back to the community. So speaking of GenkinsX, what it is. So it's an open source cloud native continuous delivery platform, an opinionated one built for Kubernetes. So if you need to remember two things about GenkinsX, it's that it is a set of practice first, and then an assembly of tools based on this practice and implementing them. So the main practices are defined in the Accelerate book. So if you are into continuous delivery and you don't know that book, I really recommend it to you. There are lots of good practice explained. And the practice that we are using in GenkinsX, for example, are GitOps, ChatOps, automatic promotion, and so on. And some of the tooling we are using, Helm for the packaging of the application in Kubernetes, Tekton for the execution of the pipeline, and so on, and Grafana for the observability part and visualization. What part of Grafana we are using in GenkinsX? A few. We are using the excellent Prometheus integration, of course, to be able to visualize all the Kubernetes cluster metrics and all the metrics from GenkinsX component, Tekton, Lighthouse, and so on. And also the application which are deployed by the user using GenkinsX in their own cluster. We are also using Loki to ingest the logs. And we are starting to use the Loki API to retrieve the pipeline logs directly from Loki instead of using the Kubernetes API. And lastly, we are using Tempo for the distributed traces. So we have support for pipeline distributed traces, the application traces, everything using OpenTelemetry. So Grafana is installed and configured using the official Helm chart. So everything is open source, so you can check it out if you want to see which version we are using, which value, and so on. And yeah, having Grafana set up by default and configured the right way in NGINX is a good opportunity for people using NGINX to do continuous delivery in Kubernetes, to also start instrumenting their application if they want to, because everything is already there for them. So we come, the NGINX comes with a few dashboards out of the box. So this is an example, for example, for a dashboard for Cert Manager. So the interesting thing here is that we can mix multiple data sources inside the same dashboard. For example, on the top, we have metrics coming from Prometheus, and at the bottom, logs coming from Loki. So we can mix everything inside the same dashboard, and it's very easy to see when we have errors, what are the exact errors. Another example using Tempo. So we have an open source application which is collecting Kubernetes events, and it is able to generate distributed traces for our pipeline. So from the GitHub event down to all the steps in the different pipelines, including the Kubernetes events, like how much time it took to pull a container image and so on. So it's very nice to be able to identify the bottleneck in your pipeline, what is taking time. So yeah, the nice thing about Grafana is that we can visualize a lot of different things from different data sources inside the same UI. So now I'll get into more details into the continuous delivery indicators, which is the core part of that talk. So as I already said, continuous delivery, it's a core practice for us and very important. It's critical to our workflow, the way we are developing and deploying application. So being able to, so if we want to improve it, we need to measure it first. So first question is, what do we want to measure? What do we need to measure? So in the industry, there are a few standards. The main one are the DORA metrics. So DORA stands for the DevOps Research and Assessment Group. So they define 4 key metrics: the mean lead time, deployment frequency, mean time to recover, and change failure rate. So basically, these 4 metrics are used to group every team and organization into different into different group depending on your velocity and so on. So it's a good way to see how you can compare yourself to the rest of the industry. So every year they are collecting data from a lot of different enterprise to build their reports. And more recently, a few months ago, there was an article about a new framework called the Space Framework, which is going further. The idea to say the DORA metrics are good, but it's system metrics only. It doesn't take into account the human and the human feelings, which is very important, even more these days with the pandemic and everything. We get to work in different situations. So the idea here is to merge system metrics with survey data collected from the developers, for example, and to group these metrics into different categories. So 5 categories: satisfaction, performance, activity, communication, and efficiency, and being able to get a higher and bigger picture of how your organization workflow are performing in the global sense of performance, including satisfaction, efficiency, communication, and so on. So yeah, the end goal is really to gather insight on the performance of your continuous delivery platform and practice, being able to identify the bottleneck, and more important one, take action, because it's continuous improvement. So that's for the global definition of continuous delivery indicators and why it's important. Next, how we implemented that. So we did that in 3 phases. First, we collect data from and events from different systems. The main one being the Kubernetes API and GitHub webhooks. So it's GitHub in that example, but it can be GitLab or any other Git system, hosting system. Then we are storing everything inside the PostgreSQL database. So the raw data for the pipeline, the pull request, release, deployment, and so on. And then we are deploying a Grafana instance and connecting it to our Postgres database using a PostgreSQL data source to be able to visualize and build dashboard and alerting everything. Because Grafana is very easy to use. If you know SQL, you can do a lot of powerful things. So everything is open source. You can check it out on GitHub. Here is an example of one dashboard for a single application. So this is data for the last 2 weeks. So for one sprint. So you can see that we have different metrics we are collecting and indicators. So for example, the time to review, which is something important for us because, and also that's something on which we can act if it's become too low. The number of releases which are waiting to be deployed in production, number of percentage of release which are deployed to production, because every time we are merging a pull request, it's going to create a new release, deploying automatically to staging, but it's a manual deployment to production. So we want to make sure people are still deploying their new feature to production. So pipeline duration and so on. So as I said, we are deploying Grafana with Helm on Kubernetes. So it's very nice because Grafana has a very good support for Helm on Kubernetes. So we can there is a sidecar feature. So if we enable them, we get a sidecar which can automatically watch Kubernetes config map or secrets resources in your Kubernetes cluster to automatically discover Grafana dashboard and data source. So what that means is that, for example, if we want to have a single shared Grafana instance, we can just define a new Kubernetes secret with our PostgreSQL URL and credential, and automatically, and with the right label, and automatically Grafana will create a new data source for PostgreSQL that we can use. And it will be the same for the dashboard. If we create one config map, for example, per dashboard, and we store the dashboard in JSON format, then our shared Grafana instance will automatically discover the new dashboard and make them available. So that's great because we can reuse a shared Grafana instance. It's GitHub friendly. Everything can be stored in Git, which is one of the core principles behind NGINX. If you want to go one step further, there is also a Grafana operator, which has a few benefits on top of just storing a dashboard in a config map in JSON format, for example. With the Grafana operator, you get a custom resource, Kubernetes resource for the dashboard, where you can add meta information on top of your dashboard, such as which plugin it needs and in which version. And the operator will automatically take care of installing the plugin in the right version before installing your dashboard. So that's something that might be interesting for some people. And once again, it's open source, so you can check it out. So if you want to go one step further, the last issue, which is about dashboard ownership, we have, let's say we're starting to have a shared Grafana instance with more and more data sources, and people are going to write more and more dashboard using mixing of data source and data from different sources. And we don't know who is going to maintain the dashboard. People are just going to create new dashboard and forget about them. So one solution we're starting to apply is to store the dashboard for one application, one repository, inside the repository itself, in the Git repository, in JSON format, and expose it as a config map inside the application Helm chart, which is also defined in the same Git repository. So the big advantage of that is that we have a clear ownership because it's in Git, so we know who changed that and who is maintaining that. There is a clear shift left paradigm. So it's part of the pull request. So when you are going to write a new feature and you're going to add a new metrics, you can also change your dashboard as part of that pull request and deploying it in a preview environment in JenkinsX, you're going to be able to test it before merging it into master and deploying in staging and production. And in conclusion, if you're going to deploy Grafana in Kubernetes, you should already have a look at the way it can dynamically discover resources such as data source and dashboard, because it will allow you to keep a single shared Grafana instance instead of multiplying Grafana instance per use case or per application. And with that, you're going to be able to build new dashboard and new alerting rules based on multiple data source. So Grafana on Kubernetes, it works very well. That's it. If you have questions, please ask them now or later if you want, on Twitter or on the Kubernetes Slack channel for JenkinsX. Thank you.
Okay, so yes, if you have more questions, now is a good time. So there are 2 questions already. So the first one is, are you planning to update the dashboard templates for Grafana 8 anytime soon? Yes, of course. I need to take the time to do that. So of course, the dashboard templates, and also how we are packaging the dashboard with everything changing in Grafana 8. I'm sure there are new ways to do it. So I need to have a look at what we can do now to improve what we already did, but for Grafana 8 this time. And yes, very important thing too, it's about the alerting. So right now we don't have a lot of things around alerting in JenkinsX, because alerting in Grafana so far was not so great. Well, it was great, it was working, but it's difficult to set up in a way that can be easily reused and extensible by user. So now with a new alerting system in Grafana 8, we'll have a serious look at what we can do with it. And I'm sure we can build great things on top of it. So yes, we'll definitely improve what we did to use all the Grafana 8 features soon when I will have time. And the second question is, can you share more about your experience with Tempo as a tracing backend? How are you managing trace before that? How were you managing trace before that? So before that, nothing, at least for JenkinsX. So we started using distributing trace with Grafana and Tempo. Because it's very easy with Tempo it doesn't cost a lot to store distributed traces. And we already have UI, our own UI, so we can already create direct links to Tempo with a trace ID and so on. So some people see Tempo as it has downside, the fact that you can't search easily based on different metadata and so on. But for us, it's not an issue because we have our own UI, so we can directly point to the right trace. So for us, it's very great. So yeah, very great experience with Tempo. It's easy to set up. So great tracing backend. And there was another question that disappeared. Okay. I lost it. So if the third question maybe is coming back, can wait a bit. Did you use Sentry before? What was missing in Grafana Tempo comparing to Sentry? No, we never used Sentry. So no. So if you have more questions, and then I think we'll wrap up. So if you have more questions, and then I think we'll wrap up. Okay, so thank you for your time, and yeah, have a great Grafana conference online. And if you have more questions, you can always come to the Kubernetes Slack community on the NGINX Slack channel. Thank you. Bye.
Hello, everyone. My name is JD Maloney. I'm a senior HPC storage engineer within CSA. And today I'm going to give a talk on enhancing observability for HPC infrastructure with Grafana. So to start off, I just want to say that I couldn't have survived this past year without Hillary. She's been working here at home with me and doing her job, and it's been fun to get to watch her do her daily job. I don't usually get the chance to do that because we work in separate places, so it's been kind of fun to get to watch her do her thing every day. It's been kind of fun and helped keep things interesting during the pandemic. So first of all, who is NCSA? We're the National Center for Supercomputing Applications. We're an HPC center that's homed on the campus of the University of Illinois in Champaign-Urbana. We operate right now 7 HPC systems with 1 new one coming online soon. And we support over 3,500 scientists and researchers right now. And that number will almost double with this new system that comes online. So to start off the agenda for today, I'm going to talk about HPC and the fight against COVID-19, and then talk about what our infrastructure looks like, and then how Grafana helps our users, followed by how it helps us, and then kind of wrap up with some of our future plans for our use of Grafana. So to start off, back early on in the pandemic, it was quickly realized that HPC was going to be a key tool to help fight COVID-19 in terms of simulating drug effectiveness and modeling spread of the virus. And so on March 22nd of 2020, there was a consortium that was formed of a bunch of HPC sites, both in the United States and then around the world. And NCSA was participating in that and allowed users to use some of our systems for a time. So also the infrastructure that was used to allocate users onto these systems to do their work was run by the Exceed allocation system, which NCSA is kind of the lead site for. And so if you want more information on how HPC has had an impact on COVID-19 research, feel free to check out those 2 links there. There's a lot of good information there. So some of the things that we did, obviously that Exceed allocation system, like I mentioned, we've given users time on Blue Waters to help them run code on that large system. And also we have an advanced computing health enclave, which allows us to process HIPAA data in a very high performant way. And we've allowed scientists to use that for COVID related research, as well as some of our other systems that support in-state research for modeling and virus spread. So in general, though, what does HPC infrastructure look like? It comes in a lot of different shapes and sizes. It's not all the same from site to site, but there's a lot of common components that they all use. So a lot of them, you have a lot of compute nodes, and then you have a low latency and high speed fabric that connects them all together. Then a high performance global file system that can be tens to hundreds of petabytes in size. It's a single namespace that can go from tens of gigabytes a second to terabytes a second even. And then there's other nodes for users to use, so like login nodes, data transfer nodes, other service nodes, and provisioning infrastructure. So the size of these components, how much they have, the ratio of them changes from system to system, but that's kind of the basic building blocks of it. And the supercomputers are used to help solve problems that are tightly coupled, requiring a lot of computers to be together working on a big problem together. So some infrastructure, just some pictures of what some supercomputers look like. There's a few here. So our Blue Water system, the Summit system down at Oak Ridge, NERSC, their Cori system, and then just a couple other systems that I got pictures from on the internet. So these are kind of what some supercomputers look like, but they all look a little different. But our needs in HPC are expanding. So as data sets get bigger and bigger, researchers don't always want to move their data back and forth, even though we're getting these faster networks that are crossing the country. These data sets are getting bigger and bigger too, and it's making it hard for them to move their data. So we're trying to bring some more persistent services to their data alongside the supercomputer compute that we give them. So users want to be able to run databases that contain job results, operate web portal front ends to allow other researchers to explore their data sets, and other tools like Jupyter Notebooks and things that help them interact with their code. So this now has us running some OpenStack clusters and Kubernetes clusters around our supercomputers that help us service those needs for users. We also have the infrastructure that sits around that infrastructure. So things like power distribution, cooling, and even the weather impacts how we operate our data center. So we need to monitor all of those things to make sure everything's in line with what we expect it to be. So in short, we got a lot of components we need to keep track of, and it's just going to get more and more complex as we go. So we need a tool that helps us kind of manage that. So Grafana helps us obviously as engineers, but one of the big things is it helps our users, and that's kind of obviously our first goal. So our users, though, in general, are scientists and researchers from academic institutions, from private companies and organizations, and then we also have managers at those companies, and then internal program managers within our center, and then also even the curious public. We're working on getting some dashboards out for the public to use to see what we're doing here at NCSA. So this is a pretty wide, varied base, of users. And so we wanted a tool like Grafana that could help us kind of manage that for all of them. So one of the things that our users might see is a project storage dashboard. Research teams get storage allocations on our systems, and it's handy for them to know, who in their group is using what and how much, so they can kind of manage their usage and also plan future allocation requests so they know what they need. Also, some of our bigger projects get their own dedicated queues on systems, and so they'll want to track, how well they're utilizing their queue, what that looks like, and then even detail metrics as to like who's using how much memory in that queue, or how many thousands of cores that queue is being consumed by what user, and then just over time, how well are they using their resource. So this again helps them kind of plan their utilization and understand why things may not be running, or where they are running, or what they can do to help increase the throughput on the system for themselves. Also, they run jobs on these systems, and so it's helpful for them to understand, job profiles and how their code executed on the system. So they might be able to plug in a job ID here on one of our job dashboards, and then that will give them a list of nodes that job ran on, and then they can click a button to set their time range of the graph to the time range that spans when that job ran, and then allows them to see some really cool things like, how the memory usage of those nodes they ran on trended over time, or the CPU or GPU utilization. Also, how much file system IO did they do while they were doing their job. So this helps them see a lot of information, and we're working to add more to this all the time. Also, for certain projects, we're helping them optimize kind of how they size jobs and move data through the scheduler. And so, so you'll see here one of our dashboards that we did with one of the 3D plugins for Grafana, where we're plotting the size of jobs in terms of number of cores, amount of memory, and then how many of those jobs of that size ran. So this allows us to very easily kind of visualize and see the spread and pattern of jobs, so that we can know, how do we configure our queues to more optimally increase throughput on the system for our users. So these are just a few of the ways that users interact with our dashboards and services. So we're adding more of them all the time. We're kind of, like I said, trying to get more data onto that job dashboard. And we're getting ready to stand up a big system that has new GPUs in it, and a lot of them. So we're working to increase our GPU statistics collecting. Also, power and cooling is something that we're just now starting to gather in as well. So there's a lot of stuff there that we're trying to add for our users. And so far, we've gotten a lot of good positive feedback from them, and they've loved interacting with their data over Grafana versus some of the more primitive ways that they had before. And the federated permissions in Grafana really help us do this in a secure way with a varied user base that has different roles and different access needs. And then for us as engineers on the back end, it provides us with a few things that we really liked. Centralized all of our metrics together into one place. And it gave us an easier way to see things, better visibility, to look at trends and correlate things together. And then also trend-based alerting is really important for us, so that we can kind of see over time if there's thresholds that are getting too close, or other things that are going wrong. So that's really important for us. So in our specific case, we backend our Grafana instances with a big InfluxDB installation. We have two 75 terabyte InfluxDB servers that are redundantly placed in separate data centers, and we have metrics shipped to both of them from Telegraph. We also have a few small MariaDB backends for certain data sets that just make more sense to be in there, and some of the tools automatically dump into that database. So Grafana handles both though just fine, and it's great to have both even on the same dashboard. Because one of the things that we struggled with here is that a lot of the vendors that we procure solutions from, they do have dashboarding capability. It kind of seems to be table stakes for a lot of things these days, but they all kind of have their own dashboarding system that's kind of their own thing. And so you get this segmentation where you have to have like 20 tabs open to see everything, and then try and correlate stuff across the tabs and see what lines up. But getting it all kind of into one place was really important for us, because this just doesn't seem to be manageable. So we need that single pane of glass, that one place that users can log into and see things. And then we use that federated access via Teams to kind of lock down folders of dashboards and dashboards individually, so that only the right people can see them or edit them or manage them in certain ways. So also, it helps us organize our data in ways that make sense to our operations. So we like to group our data by system, because our systems are tightly knit, and it's important for us to know, how those components are doing together. And so Grafana allows us to organize the data in a way that just makes sense with our infrastructure. And also it helps us with reporting. A lot of our systems have annual or quarterly reporting requirements. And so we want our engineers to spend as much time as we can on improving the system and rolling out new features for users. And Grafana helps us generate our reports quicker so that we can get back to doing that type of stuff. So some of the dashboards, just to give a sample of a few that we use internally here. So things like power monitoring is good for us. We like to use that so that our facilities folks can make sure that we're balancing power across the correct phases and building fees that we have. And so we can get rack power down to the PDU, down to the bank and to the phase. So we can plot all that in a nice, easy way for people to see what's going on. And then people can even export this data into CSV for billing purposes later also. And then for one of our OpenStack clusters, here's the dashboard that we get to see on the back end, and lets us know, how much of all these resources are being consumed, but also things like, the popular instance flavors that people are spinning up, so that we know, which instance people are preferring to spin up, so that we can kind of size our hardware accordingly as we grow. And then also for some of our big batch systems, we like to be able to see overall utilization, job throughput, how busy the cluster is, what users are submitting which jobs, just so we can track things in an easy way. And then of course, things like host telemetry. There's a lot of information that comes off of our bare metal machines that we want to keep track of and make sure that all is functioning well. So that's, everything from, power and temperature monitoring on the hosts to input voltages, making sure all the system D daemons are running properly, memory utilization, disk utilization, a whole bunch of stuff that's listed down there. Also things like FlexLM license metrics, Condor scheduling, and everything under the sun that we need to do. We kind of all have it in Grafana now. And many of these things have alerts associated with them too. So every minute, Grafana is processing about a couple million metric streams that we're looking at to make sure that they're all within certain parameters and that everything's operating smoothly. And then also Grafana not just only helps us, day-to-day during operations, but also like when we're checking a system out after a planned maintenance period, we can turn Grafana alerts back on, make sure that everything passes, and then we know that the system's pretty close to being ready for users to get back on the system. So some of our future plans for Grafana is to adopt some of the alerting changes that are coming here soon. We're really excited for those, and also for the continued expansion of these dashboards that we're working on. For users that have persistent services that are running, we need to give them better insight into those, and then even more job-related data. We want to give them more of that. And also on the engineering side, we're getting some direct-to-chip liquid-cooled systems here, and we're going to be monitoring those and checking for pressures and leaks and other things like that. So we'll need to be monitoring that. And then also bringing in logs with an Elasticsearch backend, and then just other ways that we can enhance service monitoring so that users can be better aware when a service is degraded or having issues. So, and also, of course, we'll work on whatever I get asked to work on tomorrow for this. We get requests almost daily for new things. So there'll be even more in the future here. So that's all I have for today. My contact information is there. Thanks for listening.
Hey everyone. So yeah, I'm gonna read through some of these questions here that are showing up in the slide.io. First question is, how do you handle resource security for your users? So for us, we don't allow non-admin users to have any edit powers or admin powers to our Grafana instances. So they're just acting as regular users. So we make sure that they don't have a way to access the ability to change queries or be able to create any new panels that have queries at this time. Our dashboards are just for users to kind of view themselves and just to consume data from. So our users are just consumers, so we don't let them have any data source query access. In terms of template variables and search, implementation tips for those. Yeah, so template variables are really cool, and they're really handy for a lot of stuff that we do. Honestly, I think the documentation for those on Grafana's webpage are really good for those. It's what we used when we went through and learned how that worked out. So I'd look there for those. And yeah, search is yeah, just that kind of goes along with template variables. You can search in template variable fields. So maybe just educating your users as to how they can plug and chug stuff in there. So for that 3D panel, I forget the name of what that panel is, but it is in the panel library, or not panel library, sorry, it's a plugin, right? It is a display plugin. So that was something that was already, it's like a 3D plot something or other. I can't remember the name, to be honest, off the top of my head, but we didn't have to do anything to do any custom code for that. That was available. We just had to install that plugin and then use that. So yes, that was really cool. We really enjoyed that. Took a little while to figure out exactly how it worked, but once we got the hang of it, it was really cool. Yeah, so we really like that. That's a really cool plugin. But yeah, it's free. It's on the plugin website. So, so recent projects, some recent research projects in NCSA we should check out. In terms of research, there's a lot of cool stuff going on right now with AI. We're doing a lot of stuff with GPUs. We have some DGX boxes we're doing some work with, and a lot of researchers are doing work out of the AI Institute that's here. There's also Center for Digital Ag that is headquartered here now, and so there's a lot of cool stuff that will be coming out of that as that spins up. So there's a lot of cool projects that are going on at NCSA. Our website has a lot of them, and we'll have more of them here as those kind of keep going. So yeah, our website team keeps that up to date pretty well. So yeah, so that's what we have going on for recent projects. We're going to be installing a new system called Delta here over the next few months, and so that's going to be a fun. It's not a research project from a science perspective, but it's a fun one for us as engineers to deploy those types of systems. So and there'll be a lot of good research that comes from the users who actually get on and use that system that we're excited to see and watch them do really cool things with that system. And that's also a GPU heavy system, so that'll be really cool. Yeah. If there are any other questions, I'm not seeing any other ones here in the chat. If you have any more, feel free to drop them in Slack. I'm watching that GrafanaCONline Slack channel. So if you have any further questions, or if you're not able to type fast enough, or you want to find them later, feel free to drop them in there in Slack, and then I'll be happy to answer them there. So thank you all for attending today and for listening to the talk, and hope you all have a great day.
Hello, everyone. Thank you for joining us today. So in today's session, we will be showing you how Salesforce using Grafana Stack to visualize and manage overall service health and alerts. We closely partner with the Grafana Labs that we leverage Grafana full stack to provide a cutting-edge modern technology to our community that our developers love to build a solution with. These include Grafana dashboarding, Prometheus, Loki, and other cool plugins. My name is Francis Zhao Press. I'm leading Salesforce Monitoring Cloud Product Management. So I drive our observability investment supporting Salesforce services, such as our CRM application, Marketing Cloud, Commerce Cloud, and other services as well. And before we start, I think there's one very fun slide the Grafana event team has provided for us all talk about the one thing, you know, if there's one thing last year we couldn't survive without. So we did a fun survey in our team. So this is all a vote from our team. You know, number one thing is really our family, you know, the family members, including pets, all our working partners. Another thing is to be, you know, stuck at home, working from home, work-life balance, super critical. How do we balance ourselves, you know, between sitting in front of a computer whole day and make sure the wellness, make sure our body continue function. So home gym, politics, another thing was really important for us. And of course, we cannot forget, we have to connect well with our team, with our family, with our friends, like Zoom, Google Meet, all video conferencing is really critical as well. Another thing is, given that we all have been, you know, not going to restaurant, so food delivery is very important. Of course, very important. We want to take a walk, running. So running shoes, these are 5 of us, we have these our vote. Let's move on to next. I would like to really introduce our team who will be presenting today. We have Pavan from our Service Health Insights team. He will be showing us how we leverage Grafana dashboard in managing our service health. We have Sanjana from our monitoring cloud team. She will be doing a deep dive about how we leverage Grafana stack to do super fast alert solution, and also how we provide auto remediation, auto scaling, and all automation solutions as well. I know we have our John from our database team who is going to show us how we leverage Grafana dashboarding and a solution managed service ownership. And also we have Joe from our Commerce Cloud team going to do a case study, have an end-to-end solution, talk about how we exactly manage our service health, how we tied into all fantastic product and integration pieces from Grafana to help us to do that. Let me start with a quick introduction. In Salesforce, we are moving to our service ownership journey. So here, one very critical piece for us is availability. How do we support availability? It really starts from how services define their service managers, SRO, SI, how they set up, configure, alert, and how we manage our incident. Not only about the proactively we work on our application to make sure it is supported this journey, but also we have our solution to tie end-to-end, help us to manage service health and a service incident as well. So in our stack, we have a few products. We have metrics alerting solution with a product we call Argus. We also have log analytics with Splunk, with Huron, Cypher, which are two products we implemented in Salesforce. We have also synthetic testing with the Kaiju, and we have distributed tracing as well. So on the right hand, very important is we leverage Grafana Labs cloud native solution, help us to manage low latency alerting, help us to do auto remediation, auto scaling. What you can see here is we have a hyperlocal solution with a Prometheus, with Alert Manager, with a Grafana dashboard. And Sanjana will be doing a deep dive in this space, and they will show you how exactly we have done it. So next, I would like to introduce Pavan, who is going to talk about how we leverage Grafana dashboarding, help us to manage Salesforce service health and provide visibility into this space as well. Pavan, hand over to you. Thank you.
Thank you very much, Francis, for the introduction. Hello, everyone. This is Pavan. I'm going to talk about how we derive service health insights at Salesforce using Grafana today. I'm a principal software engineer at Salesforce. I co-lead engineering initiatives related to availability insights and reporting cloud. Let me introduce you to my cloud. We build tools and frameworks for SLI dashboards, SLI alerts, and automated availability analytics for all services at Salesforce, around 1,000 plus in number, operating in various regions all over the world. Our products enable SRE to ensure that services are enabled with proper monitoring before they go live in production. And our service owners use our dashboards to monitor service health in real time after the services go live in production. And then our execs and cloud leaders use our health analytics dashboards for tracking missing SLOs and analyze service health week over week so that we can improve our service reliability based on the learnings. Let me introduce you some standard terms that I'm going to talk about in my session. SLI, service level indicator, it's kind of a quantitative measure of an aspect of your service. Let's say availability, my availability right now is 99.1%. And SLO, which is my service level objective that I want to meet. So let's say I always want my availability to be 99.9%, that's my SLO. And here are the standard SLIs that Google has introduced to the industry: request rate, error rate, duration, and all. We have added availability and saturation to this list and prescribed for every Salesforce service to emit these as standard golden health signals. Here onwards, I refer to these as reads in my demo. Let's see how a typical service health analytics lifecycle works at Salesforce. Our service owners architect their service and define a service. They instrument the service for telemetry, and then they carefully define their SLOs and SLOs and set up alerts based off that. And then they use our tools to monitor the service health in real time. And then they use our analytics dashboards to analyze the service health week over week. And then this process is continuous. Now, let's see how different systems at Salesforce bring together this process to life and how Grafana plays a key role in this journey for us. We have our services being registered in our internal registries, and our service owners use our internal deployment tools to deploy our services. And we have our telemetry platform that is Argus, which my colleague is gonna talk in the next session. And then we have implemented a framework called Reads framework that every service owner at Salesforce, around for thousands of services, register their SLA configs with, which drive the Grafana dashboards for reads. And these dashboards are used to validate the onboarding of a service on reads. And then the same dashboards are used to monitor service health in real time after the services go live. And then we use the same framework, Reads framework, to implement the dashboards analytics for service health analytics in Tableau. Let's see how our service owners define an SLI using our Reads framework. As soon as they launch our intake portal, they can see that our system has discovered all the services, around 1,000 plus again in number, and their service instances. Now they navigate to their own service. Let's say I'm taking an example of HBase here. Now they see that there are two instances our system has discovered for HBase. Now at this point, we can safely assume that HBase is ready to onboard reads. And then they see that the SLIs are yet to be onboarded. Now, as they navigate to the service definition file, they see one section each for each of the SLIs, and that has metadata such as what the SLI means for them, and then how it's calculated, and what is the exact expression used to retrieve the metric data points from Argus system, and some thresholds that that can help the service health be indicated in terms of red, green, orange on the Grafana dashboards. Now let's say the service owner filled all this data and submitted. As they submit, they can see a link to the Grafana dashboard right in the form, which they navigate to, and this is our Grafana Reads dashboard that every service owner uses to validate this SLI onboarding and to monitor production health. Now, a row in each of the results here represents the health of a service instance for the given service. And this is one single dashboard that works off around 5,000 plus distinct expressions and threshold configs configured by our service owners. And then we have around 9 dimensions to filter the service instances, which are around 10,000 plus service instances in all. And given the scale of the data being reported here, we have implemented pagination to make sure that the users only view the health of around 10 service instances at a time, so that the dashboard is always performant. And let's dig into the custom panels that we have implemented in this dashboard. The first one is the title panel, which shows the service details, the deployment context. The user can navigate to the info pop-up to see more details about the service. They can see details like service owner team, so that SRE can reach out to them in case of an issue. This is a custom panel. And then we have these other panels, stat panel for availability, and then a graph panel for request rate, and stat panel for duration, etc. All of these are custom panels. They have a custom pop-up also that provides more context into the SLI. For example, whatever metadata that service owners have configured in the intake UI, they can see it here. And they can also explore more about each panel to see a single time series version of it. Now, all of these panels are implemented using Grafana 7's React and TypeScript component library. And that's how our service typically gets onboarded on their SLIs using our system, provided that some special services stick to using some template expressions, the onboarding is totally touch-free. And these same configs are used to set up SLO-based alerts, which the feature is coming up. And then we deploy all these alerts using automated tooling, which our colleague is going to talk about in a bit. And the same configs are used to generate the automated analytics for ops review discussions week over week. As you can see, service owners can see the service instances that are missing SLOs. They can analyze the trend of service health week over week here. Now let's see how the reads framework works. So our service owners use our config portal to define their services. These configs are captured by our reads framework into a metadata store. Our framework also detects the internal service metadata from other systems. All this data is exposed via API. Now we have implemented a custom data source at Grafana end to retrieve this data for the Grafana dashboards. And then we have implemented custom panels that make sense of the thresholds that are being fetched from these objects. Now let's see what's different about the reads dashboard. Typically, this is how you set up a Grafana dashboard. You configure your template variables to represent your infrastructure filters. You pre-configure your panels with static queries and thresholds, and you configure them with a template variable so that you can report health at service instance level using the repeat panels or rows feature. As you can see, this will work for static set of queries and thresholds. But then what if you have around reads like system where you have 5,000 different query templates thresholds, which you cannot simply save within the dashboard JSON, and the dashboard has to be pretty dynamic, showing the health of around 10 service instances at a time. Now, these are the Grafana features that we leverage to implement this dashboard. We have implemented a custom data source, as I've been mentioning, to retrieve queries and thresholds dynamically as services onboard these systems at their own cadence. And then we have implemented, we have represented the template variable result as a JSON object so that the custom panels can make sense of the thresholds while rendering the health. And then we have implemented, we have leveraged the repeat rows feature. We've implemented the APIs to be paginated so that we only show one page at a time. We have implemented custom pop-ups in the panels to provide rich context. So what's our key takeaway here? So Grafana enables us with a lot of native features that are rich and allowing us to customize the dashboards. And not only that, we can integrate it with metadata coming from internal systems, which includes something core to the dashboards, such as expressions and thresholds as well. And then we can extend on the native feature set by building rich custom panels using the React and Java TypeScript component library to produce these dynamic and complex dashboards that can work at scale. And we love it. Thank you. And back to you, Francis.
Thank you very much, Pavan. This is super exciting. Next, I would like to introduce Sanjana. She's from our Monitoring Cloud organization, leading lots of initiative around our hyperlocal observability and automation. Hand over to you, Sanjana.
Thanks, Francis. Hi, everyone. I'm Sanjana Chandrasekhar, a lead engineer on the observability team here at Salesforce. I will be walking you through a new offering that Monitoring Cloud provided to our customers, and it's called Hyperlocal Observability. So to give you some background on what hyperlocal observability is and why we brought it into our ecosystem, I would like to quickly dive into Argus, which is the time series monitoring platform here at Salesforce. So Argus allows engineering teams to ingest, store, visualize, and alert on massive amounts of time series data. So with all of this data, Argus has the advantage of providing capabilities for performing advanced data analytics and providing smart alerting and dashboarding solutions. So with this diagram here, it shows us the metrics ingestion flow. So the metrics flow from the Kubernetes clusters that services are running in to a local Kafka cluster, which then goes into an aggregated Kafka and then gets ingested by Argus. So as you can see here, the ingestion goes through multiple hops and each hop adds latency. So with a move to a highly distributed cloud-native architecture, Salesforce needed a reliable alerting system that can provide near real-time feedback. And so to fill this need, our organization, Monitoring Cloud, provided hyperlocal observability, HLO for short, which is a package set of open source and cloud-native observability tools. So it bundles Prometheus, Grafana, and Alert Manager in an easy to install and a highly customizable package that engineering teams can then deploy and operate within their Kubernetes clusters. Hyperlocal observability works in conjunction with Argus to enable a comprehensive, low latency and highly available alerting solution. So Argus is still the destination for long-term and federated metric querying and viewing, but HLO complements that and plugs in the latency gaps. So here's a brief overview of how it works. So when a service team deploys a Kubernetes cluster within their service, they can also choose to bundle hyperlocal observability along with it. So the Prometheus pod here is configured to work with service discovery and find open metrics enabled collection endpoints. So Prometheus also pulls metrics about the health of Kubernetes objects and can be configured to read cloud-native metrics from providers like CloudWatch. The packaged Alert Manager is used for notification routing and snoozing with support for Slack and PagerDuty notifications as notification targets. The Grafana instance visualizes metrics scraped by Prometheus, and it comes with a set of pre-configured dashboards to help monitor your Kubernetes workloads and is really helpful for debugging issues. So HLO enables a lot of use cases on our side and brings with it a lot of benefits. So the biggest is the ability to provide low latency alerting. So since HLO runs as a part of the Kubernetes cluster, it eliminates multiple hops and can provide sub-minute alerting capabilities. So this has helped us reduce our mean time for detection and mean time for resolution by almost up to 80%. It also helps with auto remediation. So because it is so hyper-local and is part of the same Kubernetes cluster, it makes remediating incidents within the cluster very easy, fast, and very automatable as well. It also gives us the advantage of horizontal auto-scaling. So service owners can connect the Kubernetes horizontal pod autoscaler to Prometheus to automatically scale up their workloads or scale it down based on resource usage, which helps reduce our cost to serve. We also rely on it for build promotion. Service teams will be able to define rules around their service health metrics to programmatically decide if a build can be promoted to a production environment. So this means that engineers will spend a lot less time verifying every release. So given these different alerting and dashboarding solutions that we support, there is a big push to allow for automation to make managing them easier. So that brings me to my next topic, automation tooling. So a lot of the service teams here at Salesforce are moving to the infrastructure as code model, and we have tooling to support this. So on the tooling front, we have monconfig, stands for monitoring configuration, which is a homegrown tool that allows defining Argus alerts, Argus dashboards, reads metrics, and Grafana dashboards as YAML-based configuration files. We also have custom Terraform providers to configure these artifacts through Terraform. So let's talk about why we developed this tooling and the benefits that these tools offer in the context of Grafana dashboards. So one big thing is it allows for templating. So these tools support the substitution of different variables across dashboard templates, and it makes it easier to share templates across different dashboards and to only focus on configuring what you're interested in, such as controlling what metrics need to be shown and what folders that it needs to go in. So these tools also allow us to manage all of our Grafana dashboards in Git, which brings with it multiple benefits like versioning, allows for team collaboration, and all of that. So it also opens up the doors to configure our continuous deployment pipelines on top of it. So that makes it easier to deploy our changes. So having templating and versioning also makes it a whole lot easier to manage dashboards across different installs of Grafana that exist in different environments here at Salesforce. For example, consider different environments where the metric names remain mostly the same, but it's only certain dimensions like the cluster that is different. In this case, you could configure these differing dimensions as variables and have them substituted into your dashboard definition. So as soon as you check in your changes, you should see your updates reflected in both these environments as and when the continuous deployment pipelines kick in. So another benefit comes from the different integrations that these tools already support. Some of the integrations include support for the management of Argus alerts, reads metrics, and permission management on Grafana folders. So now with the Grafana integration, we're able to reference the artifacts configured through another integration and have the changes made to one artifact cascade over and update these other artifacts as well. So with solutions like HLO and tooling such as monconfig and Terraform, Monitoring Cloud is able to fulfill all the alerting and observability needs of the engineering teams here at Salesforce. Thank you all, and I'll hand it back to Francis.
Thank you very much, Sanjana. And next, I would like to introduce John O'Brien, who is from our CRM infra organization, leading lots of effort around performance. He's going to show us how dashboard that make it work. Hand over to you, John.
Thank you, Francis. My name is John O'Brien, and I'm an architect at Salesforce working in the area of performance. My presentation is about dashboards that work, and it's called Dashboards That Work because I want to help you build dashboards that will work for your users when they arrive on a dashboard to use it either for the first time or a second time and solve the problem they've come to the dashboard to work on. So I'm going to tell my presentation through three main use cases, which is trends, health checks, and performance monitoring. So first dashboard we'll look at is a CPU dashboard. And in the top CPU graph, we can see there's a threshold graph at around 80%. Thresholds are important because they show users if something is being exceeded and a user unfamiliar with the data as well. We can see that I've hovered in the middle of the dashboard and it's popped up the values at that point in time. And it's done that for the panel below as well at the exact same time. So you don't have to hover over various panels on your dashboard to see what the value was at the same time, panel to panel. That's a super useful feature of Grafana. On the left-hand y-axis, we see percentages on both panels. Grafana supports units of measure, and it's really important when you arrive on any panel and dashboards that you know the units of measure, whether it's milliseconds or nanoseconds, whether it's percentages, throughputs, etc. Grafana is very rich in terms of picking units of measure, and it scales them up as well. If you had something that was nanoseconds that was really milliseconds when it totaled up, Grafana would scale that up into milliseconds units of measure. So you don't have to worry about that as a dashboard creator. In the top left-hand side of each panel, there's an information icon. It's quite small, but it is there. And I popped up the one on the upper graph. And this allows you to tell the user what that panel is for. All panels should have this because users may be unfamiliar exactly with the use of the graph. It also, because Grafana stores dashboards in JSON format, if you do document all your dashboards completely, you could pull out that text out of your JSON and put it into a wiki or even back into another Grafana documentation dashboard if you choose to do that. Other features on these graphs are, in the top one, we can see that I've smoothed out the choppiness as well with a 15-minute moving average. And in the lower one, instead of using a threshold, what I did was I took a previous time frame and graphed the values for that between a min and a max. So you can see a band there, and the user quickly can key off whether this is inside the bands of historical values for this metric. I also use aliasing for the metric names. All too often you scroll onto a metric in a graph and you get too much metadata information about the metric. You know the server you're on, you know what you're looking at, so you just want to hover to tell you the minimum amount of information. At the top of this dashboard, there's a documentation panel. What I've done, it's called log links, and what I've done there is I used the HTML panel to put in links to other tools that we use. One of the big features of Grafana is that the calendar widget in the top right stores the selected time inside variables. So if you do go to another link, you can pass on time windows and other variables and metadata onto the other tools and onto other Grafana dashboards. In this slide, we just have the general config for the whole dashboard. The name of the dashboard is CPU. There's a description. Again, documentation is super important. The next thing is tags. Tags are great for finding dashboards, for grouping them together in lists of dashboards, and their use is encouraged a lot. I like to tell my users to create tags as single words and all lowercase. That way they're easier to find. Below that, we have some time options. We settle on a time zone for UTC. We also, below that, there's graph tooltips. That's the important of the crosshairs. If you're on one panel, it'll show up on the other panels. On the left-hand side, we can see variables and there's links. And there's the JSON model I spoke about where you can go in and see and pull down the JSON, or you can use an API to do that. The next example we give is a health dashboard. Again, at the top, I'm using a HTML panel to do a lot of links into other systems. And these help the users jump onto those systems with the current time frame and the current parameters for this dashboard. In all the squares, we can see that units of measure, again, are very prominent. And we see information icon in the top left-hand corner of each square. So users can hover on those and see what the help is. And I've done that with the second square, which just basically shows measure of current CPU percentage. And there's a link to the CPU dashboard there. If I was to click on that link, it would take me for this time period directly onto that CPU dashboard. In the top right, there's some dashboard level links, network, memory, storage, and they also are coded to jump to other dashboards with the context information. I really like that feature of Grafana because if you're working an incident and you need to jump quickly around a lot of dashboards and follow the trail of a problem, having to type in start times and different server names is a bit laborious and can slow you down a lot when you're trying to catch something in a time-sensitive manner. This next slide utilizes one of the features of Grafana, which is around repeat options. So in this example, it's just a group of metrics based on some common things. So what I've done is I've done step one at the top and I've coded that once, and then I repeat for all the other steps using the row options widget. So it generates all the rows. Now, you can also, on each of those rows, you could repeat for the metrics all the way across as well. And you could do a repeat for inside the stat panel metric, which is incredibly useful. So they're basically the three types of dashboards showing you a bunch of features that are very useful to your users. Now, when we started creating dashboards, we had feedback from our users of difficulties. And that's what led to the way we built the dashboards I just showed you. So we came up with some coding standards around dashboards. Just like product has code, operations needs QA standards as well. And so these are the ones we came up with. The mandatory ones are have all the dashboards parameterized, no hard codes. We want the time zone always to be UTC. We want tags and how the tags should be created, lowercase, single words. We want documentation information title on our panels, with a documentation panel as well. Units of measure, probably the most important one here as well. Start and end time as variables. And we don't really like auto refresh on our dashboards because it can cause load if it's on for a lot of dashboards. So turn it off by default. Suggested ones are y-axis at 0. This is particularly useful for space dashboards where you might have terabytes of space and then you might have a change by a few gig. So if the y-axis resets to the values above 0, it can look like a precipitous drop when it's really a small drop. So setting the y-axis at 0 sometimes doesn't alarm users. So that's a good one to keep in mind. Using multi-value options is useful as well if you want to look at multiple servers instead of one. The crosshairs are tooltips, which I showed in the settings, which shows highlights across all your panels, alias as well. And the last bullet point there, which is linking. So I like linking a lot. Grafana is very rich for linking. And the major feature is that you could pass the context around to other dashboards in Grafana and also within your own ecosystem of tools that you've built in-house. So the features that we leverage chiefly, just doubling back on all that, are units of measure, built-in documentation, variables, repeat for. Then, of course, what you see is what you get. The immediate rendering of dashboard edits is super useful in Grafana. The calendar is very powerful. It leaves you with the history as well. so you can see what you looked at previously. Using the HTML panel for JavaScript is really useful as well, and we use that a lot for text help as well as links to other tools. And the last one, the JSON model for the API, pulling down dashboards, revision control. Even if you've edited a lot of panels, you can do search and replace in there as well and save back in. So my 3 major points are to create and enforce dashboard standards, leverage all the Grafana features that you can. Grafana is very rich in features. And then exploit the feedback loop between your developers and operations teams, and have a feedback loop so they can tell you what they found useful about your dashboard, what you can improve on, and then build it back into your standards. So keep in that loop. So in this presentation, we learned to accelerate the creation and launch of usable and understandable comprehensive dashboards for your organization, so you can see what's happening at all times. So that's it. Thank you, Francis. Back to you.
Thank you very much, John. Next, I would like to introduce Joseph from our Commerce Cloud. Actually, he's going to show you a story end to end, how we define our service, how we leverage observability, and how we manage our health service with the Grafana solutions. I would like to hand over to Joe.
Thank you for that introduction, Francis. And hello, everyone. My name is Joe Pilata, and I'm a software engineering manager with Salesforce Commerce Cloud. And I'm really excited to share our monitoring strategy, leveraging Grafana during the most critical holiday shopping period for our customers, from Black Friday through Cyber Monday. But first, let's start with an overview of what we do here at Commerce Cloud. Commerce Cloud is the world's most trusted commerce platform. We help companies build personalized experiences around their customers, which are extensible across every channel. The platform serves 2 billion shoppers every month, and our customers are generating more than 3 million transactions per day at a historic 4 nines platform availability. And Grafana is the tool that we use every day to monitor how well those customers are performing on the platform to ensure their success during their most critical sales events. And for most of our customers, that critical period is the week of Black Friday through the following Cyber Week. And that period is better visualized here by order volume. You'll notice the big spike representing Black Friday through Cyber Monday. The shopping holiday is when our platform is operating at peak capacity and saturated with the highest surge in customer traffic. And our customers represent a wide variety of industries, different strategies, and unique requirements, which is why our monitoring capabilities are so critical to their success. So let's discuss our customer-centric monitoring strategy a little more in depth. And it starts with Grafana, which is the window pane that provides visibility to how well our customers are performing on the platform. We've been using it in production since early 2016. We run a graphite-based metrics service powered by CarbonJ, which is a Salesforce open source Java implementation of the Carbon metric processing system for storing and querying time series data. CarbonJ is a data store that Graphite Web queries to feed Grafana. And next, for some stats. We process more than 70 million e-commerce metrics per minute. From those metrics, our internal teams have configured thousands of unique alert definitions. And our Grafana alerting, in combination with a homegrown alerting service, processes more than 120,000 alerts per minute to provide proactive monitoring capabilities to our internal teams. And Grafana is serving more than 300 active daily users across our internal teams every day. So let me demonstrate one of the primary dashboards we use to effectively monitor customer performance on the platform, and how we purposefully architected the dashboard to render key insights as quick as possible. This Grafana dashboard is a starting point for our customer-centric proactive alerting and the primary troubleshooting tool for our investigations. The first thing you'll notice on this dashboard is the overview section. By default, this panel is already open when the dashboard is loaded, displaying 6 distinct graphs that are above the fold. We designed the overview section in a way that you can quickly assess the activity across the customer sites and their overall health on the platform. You'll see the first graph depicts the activity across the customer sites. Green and red show request rate, yellow is order rate, and blue is session rate. There's a lot of questions you can answer from this graph. The first is the customer having a sale or promotion event. See a sudden spike in requests, sessions, and orders. Is the traffic organic? Or is it maybe bot traffic? High request rate, minimal order rate, a disproportionate amount of metrics. And the second graph is called busy storefront threads. This graph displays system utilization, which is a percentage of busy server threads versus the available threads. High usage is one of the key indicators that our customers are experiencing a performance-related issue on the platform. The third graph is garbage collection. This graph depicts aggregated garbage collection time spent on the JVM as a percentage. By default, we display the highest 3 consumers, which will tell us if the issue is widespread or if it's specific to a single process. The fourth graph is CPU per server. This graph normally aligns with high system utilization, and it helps narrow down the investigation and is normally accredited with customers deploying poor code on top of the platform, or code that simply doesn't scale with traffic. The fifth graph is database connections. This graph can also steer an investigation to uncover the root cause by showing the number of open and busy database connections at a given time. And the sixth graph is database I/O and rate limit. This graph is useful in assessing any issues at the storage layer. The seventh graph is third-party response times. The Commerce Cloud platform has a robust partner network supporting many integrations, including order payment processing, taxation, and shipping integrations. Third-party performance issues can degrade the platform if no protections are put in place. This is very common on the platform. So now that we've covered the overview slide, let's walk through a full investigation, starting with the activity and busy storefront threads and how the graphs are used collectively to solve an issue. We'll start on the bottom graph. This tells us there was a performance degradation between 5 and 6 o'clock. There were 2 separate spikes in system utilization. And there's a dotted line that shows when a full cache clear was triggered. The top graph tells us there were 3 sudden spikes in activity, 2 of which match the pattern of system usage aligning with the performance degradation. The detail in the first 2 graphs already narrows our investigative thinking, but also poses more questions. We know a sudden spike in traffic tied up system resources, but there was also a spike in activity earlier in the day, and it didn't have the same effect. The more recent traffic spike happened 3 times, where system usage only spiked twice. So let's continue our investigation. The top graph depicts CPU usage. We can see the CPU usage on the servers spiked in line with system usage. This tells us that the custom code is inefficient, or at least it's not able to scale commensurate with the spike in traffic. The bottom graph shows a spike in open and busy database connections. This means that with more activity, less requests were handled at the different caching layers, resulting in all requests being funneled to the database. So let's wrap up this investigation. We know that the root cause was the customer triggered a cache clear directly before a surge in traffic. You can see that with the dotted line right before that spike. This is likely a sale event, and it exposed inefficient custom code, which we see in the CPU usage. This means that all the requests needed to funnel through the entire stack, increasing the round trip time and tying up system resources in the process. You can also assess the time it took the cache to build back up, as a third spike in traffic did not impact system usage. This quick root cause analysis allows our teams to proactively identify issues with our customers, and with enough detail that allows the customer to quickly address it or for our internal teams to remedy it. So that wraps up my demo, and I want to thank you all so much. Back to you, Francis.
This is super exciting. Thank you very much. Thank you, everybody, for listening. Hopefully, we give you a taste about how we leverage Grafana solutions full stack, from dashboarding to product around the Prometheus, Loki, and the plugins, how we leverage those to manage our service health. And thanks again. If you have any questions, please do feel free to reach out to us offline, and we'll be happy to answer any questions you have. Thank you again. Have a wonderful day.
Hello again, I'm back. My name's Raj Dutt. I'm one of the co-founders and the CEO here at Grafana Labs. I'm lucky enough to have opened GrafanaCONline this year, and here I am 2 weeks later, wrapping it up with a talk about the business of Grafana. So the community is often quite interested in how Grafana Labs, the company helping push forward projects like Grafana, Loki, Tempo, and others, is actually doing as a business. At previous GrafanaCons, people would come up to me, well, back when we were holding conferences in person, they'd come up to me and they'd be curious. How's the business side going? How many people do we employ? How much revenue do we have? What is the overall trajectory looking like? Are we able to create a viable company around these open source projects? Well, we're a pretty transparent company. It's part of our culture. And every year we've shared some key metrics and given people an update on the business. And this year is no different. So before we dive in, I hope that everyone has enjoyed the conference. I know I have. It's been 2 weeks filled with interesting content, workshops, panels, some serious, some lighthearted. We've heard from our community, our customers, and from quite a few Grafanistas too. And we've had fun putting this conference together. I'd like to thank everyone who participated, everyone who spoke, everyone who attended, and most of all, I'd like to thank all the passionate people at Grafana Labs who worked tirelessly to make this conference happen, to make it a success. And they even put up with me when I failed to get any of my content done by the deadline. So sorry about that, team. I'll do better next year. Sorry for all the stress. So onto the update itself. It's been a banner year for Grafana Labs, even against the backdrop of this global pandemic. We've been hiring like mad, and I'm really proud of the team that we've put together so far. We've even gotten to the point where I can't really remember everyone's names. And that kind of scale is both amusing at times, disconcerting at times, but most of all, just generally exciting. And the metric that we care about the most, adoption of our open source projects, continues to accelerate. It's truly an honor to be at the center, for Grafana Labs to be able to be at the center of this vibrant and growing community. So as far as revenue goes, it's the stuff that obviously keeps the lights on, the dollars, that's also really trending nicely. From day one, we wanted to build an enduring and sustainable company. And I think that things are proceeding really well on that front. And then finally, our products. You know, we realized pretty early on that open source is not a business model. It's a great way, a superior way to build software, to build communities, but we don't sell open source. So even though most of our effort goes into our open source projects, which drive adoption, our commercial products are really important too. And the story there is like night and day compared to a few years ago. So before we dive into details, let's recap what our predictions were at the last GrafanaCONline for where we'd end as a company at the end of last year. So we predicted that by the end of 2020, we'd be over 200 people and over $25 million in revenue. So how did we do? Let's start with people. Now, it's funny to look back when we started back in 2015. We started with just 3 people. And over the years, we've done a lot of hiring. The first few years were slow, and it took us about 4 years to grow the team to 29 people by 2018. So between 2015, 2016, 2017, 2018, we grew from 3 to 29 people. That's about 6 new hires every year. Those were fun times. And you know, it wasn't until 2018 that we really figured out our business model. So in 2018, we had 29 people. And by the end of 2019, we grew to 106, which was an incredible year, crazy year of hiring. We added more than 70 Grafanistas. I remember thinking at the time that that pace of hiring seemed absolutely bonkers. Well, the last year, 2020, was even more bonkers. We more than doubled the company and hired well over 100 new people. So we ended 2020 at 239 full-time employees. But the craziness doesn't stop there. It's been even more insane since the end of 2020. Over the last 6 months, we've gone from 239 to about 400 Grafanistas all over the world. So we're a remote-first company. We have employees in over 40 countries and every continent except Antarctica. We're still working on that. And needless to say, we're hiring across the board. So if you're interested in seeing if there's a position that's just right for you, check out our careers page on grafana.com. And I'm obviously biased when I say this, but I think we're a pretty cool place to work. So that's people. Let's go on to adoption. We covered a little bit about this in the keynote. Grafana itself has continued to accelerate from an adoption standpoint. There are over 750,000 installations of Grafana in the wild that we see. And this adoption is really driven by the various ecosystems that Grafana plays in, whether you're using Prometheus or Elasticsearch or SQL or Azure Monitor or CloudWatch or Influx Data. All these communities are growing, and Grafana is rapidly becoming the choice of how people visualize, alert, and transform their data, regardless of where it lives. And that flexibility of being able to bring together your data is something that is really at the core of what Grafana does. We call it the big tent philosophy. And there are over 100 data sources at this point that you can natively connect Grafana to. That's the growth curve of Grafana. You can see how when we started measuring this in mid 2016, there were barely 30,000 instances that we could see. And now there are 300 and now there's over 750,000. So we've grown over the last 6 years by almost 25x on the adoption side. And this is really the metric that we care about the most as a business, because this adoption fuels everything else that we do. And then there's Loki. Loki was released 2 years ago, and the reception that Loki has gotten has been quite amazing. There's over 67,000 Loki instances that we see in the wild. The growth curve of Loki really compares and even in some ways exceeds the initial growth curve of Grafana. So when we launched Loki, we were kind of wondering whether we could have 2 successful open source projects at Grafana. And Loki, kind of proved that we could, and we did. And Loki, the feedback, again, has been absolutely tremendous. If you're using Prometheus, you should definitely check out Loki. We like to say that Loki is like Prometheus for logs. And we're continuing to put a lot of effort into making Loki even better. And then the newest piece of the Grafana Lab stack, the open source stack, is Grafana Tempo. Tempo was released only about 8 or 9 months ago, so it's early days for Tempo. There's over 6,000 Tempo instances that we see in the wild and over 1,500 GitHub stars. The cool thing about Tempo is it went into GA just about a week ago at the start of GrafanaCon. And there's a lot of sessions around Tempo. There's a lot of sessions around Loki that are available for viewing over on YouTube. So definitely check out those sessions if you're interested in either Loki or Tempo. All right, revenue. The metric that people are interested in, that I also get some flack from some people for even sharing. So as a recap, here's what we talked about at the last GrafanaCONline. So we started at about $1 million at the end of 2016, and we weren't even really a company back then. In fact, most of this $1 million of annualized run rate was consulting, professional services. We didn't have any commercial products. We didn't really have anything to sell. So we just kind of helped people with, consulting, professional services. We really weren't a product company at the time. By 2017, by kind of, continuing to do the consulting, we managed to grow to about $2 million of annualized revenue. And that was really an inflection point for us because we launched Grafana Enterprise and Grafana Cloud in late 2017. So by the end of 2018, we were at a $5 million annualized run rate. And this was a really important year for us because almost none of the $5 million of annual revenue that we had at the end of 2018 came from consulting. In fact, less than 5% of that $5 million came from consulting. And then we announced this at the last GrafanaCONline, but by the end of 2019, we'd grown to over $12 million in revenue. And we were really, really kind of quite pleased with that accomplishment. And remember, our prediction at last GrafanaCONline was that by the end of 2020, we'd try to grow to over $25 million in annualized revenue. So how did we do? Well, by the end of last year, we were at a run rate of over $30 million a year. So huge credit to our go-to-market team, which is something that we've been investing in quite a lot over the last year and a half. And if you're a customer of Grafana Labs, we really appreciate your business. We have over 1,300 customers at this point. And it's every customer helps us build both a sustainable company, but also helps us build even more open source software. So it really is a virtuous cycle. So in summary, between the end of 2019 and the end of 2020, we managed to grow our revenue by over 2.5 times, which is really exceeding expectations. Let's talk about our products. So the Grafana stack has evolved quite a lot over the last year or two. We really started with just Grafana, which is all about visualizing your data, alerting on your data, and with Grafana 7, transforming your data. Obviously, Grafana 8.0 was released last week. We're really excited about that, but we've really become a multi-project company. We now have continued our investment with Prometheus on metrics, and we have an enterprise version of Prometheus called Grafana Enterprise Metrics that adds a lot of functionality and capabilities that are designed for really large scale users. We have Loki for logs, and we have an enterprise version of Loki creatively called Grafana Enterprise Logs. And then we recently announced Tempo for traces, and we will soon announce an enterprise version of Tempo that will probably be called, you guessed it, Grafana Enterprise Traces. And so this is now becoming a stack of sorts. And the combination of Grafana, Prometheus, Loki, and Tempo is kind of like the curated stack. But Grafana is all about composability. So the support that Grafana has for Prometheus, for Loki, for Tempo, those 3 projects are just data sources for Grafana. And Grafana supports over 100 other data sources. So we're pretty unique in how we think about this stack in that it's composable, meaning you can choose to bring in your data from where it already lives. And whether your data lives in Elasticsearch or Splunk or New Relic or Datadog or Influx Data or SQL databases, CloudWatch, Azure Monitor, or 90+ other data sources, you can bring that data into Grafana natively without having to extract it, transform it, load it. And we really believe that's important because most companies, particularly large companies, will never be able to consolidate all their data into a single backend. In fact, the entire industry, we feel, has been pitching this single pane of glass, but that pitch comes with a huge caveat of having to consolidate all your data in a single backend. Grafana is all about composability. Grafana is all about allowing you to amplify your existing IT investments, and it's about choice. And in line with choice, we want to meet our customers wherever they are. So whether you want to use this stack as a self-managed product, we've got you there with Grafana Enterprise. Or if you want to get the benefits of this stack as a cloud offering, we've got you there too. Grafana Cloud is something we're really excited about. We're investing a lot in as a company. Obviously, on a long enough time horizon, the future of software delivery generally moves to the cloud. We're committed to both the on-prem version of the stack as well as the cloud version of the stack. In fact, our revenue today is about 50% on-prem and 50% cloud, but we're putting a lot of effort into Grafana Cloud. So with Grafana Cloud, you get all the benefits of the full Grafana stack, a complete observability platform with Grafana, with metrics, with logs, with traces, with all the composability that the stack offers you, but we'll run it for you. We'll handle all the heavy lifting. So you don't have to worry about the maintenance, the security, the scalability. And then the other interesting thing with Grafana Cloud that we're really excited about that kind of changed the dynamic of our business in the last 6 months is we launched a super generous, in fact, arguably the most generous in the industry, free forever plan. And that plan comes with 10,000 series for metrics, 50 gigabytes of logs, 50 gigabytes of traces, as well as Grafana itself. So if you're a small scale user or you're running a home lab, you can use Grafana Cloud free forever. And we're committed to offering this free forever plan because we really want people to be able to kick the tires in a really turnkey manner. Grafana Cloud's also really easy to get started with. There's pre-configured alerts and dashboards for all sorts of applications and frameworks and databases. So however you're building your own software, whether you're using things like MySQL or Console or Kubernetes or dozens of other integrations that we have, it's really easy to monitor your whole stack with Grafana Cloud and be able to get up and running with really nice dashboards and alerts in a matter of minutes. And the pricing for Grafana Cloud is really flexible and predictable. One last thing from me, and this is a piece of really exciting news. We've saved a major announcement for the last few minutes of GrafanaCONline. And we'll be putting out press releases and blog posts about this news shortly, but you heard it here first, and I'm really excited to share this with you. Now, before I share the announcement, I just want to put a little backdrop here to explain the rationale with the OODA loop. Now, you've probably heard of the OODA loop. It's used by a lot of different observability vendors. It was actually created by John Boyd, who was an Air Force pilot. And John Boyd came up with the OODA loop, which stands for Observe, Orient, Decide, and Act. And the theory was that you could apply the OODA loop to just about anything, whether you were in a combat situation in the Air Force, whether you were running a business and had to think about how to react to competition, or whether you're troubleshooting an alert at 3 o'clock in the morning. The idea is you respond to inputs, whether those are visualizations, spikes and graphs, alerts, switching between your metrics, logs, and traces. And you have to essentially orient yourself to the situation, decide what to do, and act. And this is something you go through constantly and repeat, potentially multiple times per minute or subconsciously multiple times per second. And the theory is the faster you can go through this loop, the more competitive you'll be. And in the case of observability, that means resolving the issue, fixing remediating the problem, optimizing your stack. But generally, when we think about the OODA loop, we think about high stress situations in production, right? And at Grafana Labs, we really want to help developers innovate faster with less risk. And wouldn't it be great if we didn't have to go through this in production? Wouldn't it be great if we could prevent problems before they arise? And so we've been thinking about this a lot lately as we try to improve the reliability of our software, as we try to create a really reliable and high quality release with Grafana 8, as we try to build a better cloud product. And we, like everyone else, we put a lot of effort into the quality of our software, things like unit testing to make sure that the quality is as high as possible before it goes into production. But there are certain issues that always crop up. That happens to any company. You can't be perfect, but you want to prevent as much as possible and catch problems before they become production issues. So a tool that we found a couple of years ago that we really like is an open source tool called K6. So this is a tweet from 2019 from Marcus, who's a core developer at Grafana. He's been with us for quite a few years now. And so Marcus says, K6, I love you. This is the second time that you helped us track down a nasty bug in Grafana that only happens under heavy load. And this was a critical bug that we really had a hard time resolving. And it was a bug in what would become Grafana 6.0. And we were able to use K6 to generate synthetic load that simulated a user that helped us find this edge case that was really tricky to diagnose. And as we started to get more and more into K6, we found that it's really useful to set up all sorts of synthetic tests and load tests that are tied into our CI. And this has helped up our quality and ultimately helped us move faster with less risk, because we can catch a problem before it's deployed to production. But it's kind of suboptimal in some ways because the K6 tool isn't tied into our larger observability platform. We'd like to use the same observability platform to see the results of the load test. So we've been talking to K6 for quite a while, and we've been really impressed with their team. Their founders, Robin and Powell, are just really talented developers. They have a really compelling vision. And above all, they're just really nice people. So the news that we have to announce is that Grafana Labs is acquiring K6. They're a crack team of about 30 people. Like us, they're distributed all over the world. Like us, they believe in open source, and they have a really popular open source project with well over 12,000 GitHub stars. Like us, they monetize that open source project with a cloud offering. And the more we talk to K6, the more we realize that our vision was aligned to create a truly compelling experience that allows you to test your software before it goes into production and tie the whole experience into a consolidated observability platform that we're going to build together. In a way, this is how Grafana Labs is going to shift left towards earlier in the software development lifecycle. And we're really excited to announce this acquisition with everyone today. And so K6 is a Grafana Labs company, and we're going to be working together to accelerate their roadmap, as well as bring some of their load testing capabilities into our observability platform. So Robin, Powell, the whole K6 team, really looking forward to working with you over the coming months and coming years. And to our community and our customers, you can expect some really, really interesting capabilities that is a result of this acquisition and us being able to work together in this problem domain. So that's about it for me. And that brings us to the end of GrafanaCONline 2021. It's been a pleasure. As a reminder, check out Grafana 8.0. We release a new version of Grafana at every GrafanaCONline. We call it conference-driven development. I hope that we'll be able to meet in person next year for the next GrafanaCon, for Grafana 9.0 and much, much more. We'll continue to be transparent and give you updates on how the company is doing. In the meantime, stay safe, stay sane, and have a great week ahead. Have a great rest of 2021. And thank you very much for being part of our event.